T8, T9. Okay, so this frame relay header is removed. Once it reaches at the router, frame relay header is removed at time T9, T10, right? At time T10, frame relay header is removed. So once again it becomes IP header, TCP header and data. So it looks into the IP header, finds out where exactly it has to forward the frame, then based on this IP header, destination IP address, it once again, because the data has, this packet has to move through the local network LAN. So what it does, it encapsulate once again into the LLC header, MAC header, right? T12, T13. Similarly, then once it reaches over here at time T4, the MAC header is removed, LLC header is removed, then IP header is removed, so that it is delivered to the TCP, the process which is running on this end user. The Microsoft team is running on this user, so it is given to the that end user application, right? Followed? So so what are the design issues basically when so we will look into it, that we talked about a bit, that what a protocol should have. So when we are dealing with, when we are talking about an IP protocol, what are the things IP should look into it? Because what are the things you should look into it? Because you are not talking about only a single network, right? You are talking about a large number of networks, that too of different characteristics, right? So how to deal with that issues, right? So routing is basically, uh, we say about the internet as a network. You can see it's a packet switched network. So you can see that there are different routers. These are the end users S1, S2. Okay, it is a packet switching network, and this is basically the internet. You can see. So there are different networks, right? N1, N2, N3. All these networks are interconnected through different routers, right? And this is finally the sources S1 and S2 source stations, station 1, station 2. So the picture difference, you can see that it is a packet switch network, and this is basically an internet where this is replaced with a network. Each network is connected with uh, so this P stands for packet switching nodes, right? Packet switching nodes, right? So as you know that the end users and routers maintain the routing tables. So maintaining routing tables means they have to indicate which next router they have to follow, forward the datagram, as we have seen in the when we did fixed routing example. So we created a central routing matrix, and then each bridge was having its own routing table, right, driven from the central routing matrix. But that was the fixed routing, right? So in the similar way, each end user and routers maintains a routing table, right? So routing table guides them that which particular node they should forward it. So what will be the next node value? Which next node it has to forward the datagram, right? So so in case of a, as you know that the routing can again be static and dynamic. Static है तो route fix हो गया, dynamic है तो it is flexible, or it can be source routing, where the source specifies the uh, route as what are the which route you should take, right? Which route the frame should take. So that is specified by the source itself. By first of all, it collects the information by sending some uh, mm, management frames like a route recording and other things. It performs and record everything, and then it asks, then it uses the same route, because those frames goes, reservation frames goes Okay, they from the source to the destination, it sends some reservation frame, okay, that collects the information of all the intermediate devices on that path, okay, and then once it reaches back to the source itself, okay, it decides that which route should be followed. So source routing, route recording facility, like whether the route can be recorded, which particular route is taken. So source routing, it is good that if you are recording the route, right? Or route recording can also be useful when you are talking about some sensitive networks where your data is vulnerable. So there, you to know that where exactly our packet is moving, right? So to restrict it or to let you know that what kind of like where exactly the packet is moving through which networks, right? So that will give you an idea of the internet. So this type of information, route recording information, becomes essential when you want to know about the status information about the routers, which are the routers are up, which are down, okay, which end user is up, which end user is down. Because when you talk about internet, okay, the number of users can change, right? The internet is growing very fast, so number of users, many new users are added every day, so you need to be updated based on that, right? So so like that, many new networks are coming, so like that, you should have a feature like route recording that records the route and keeps you updated, right, in making routing decisions. So there is a another important thing is a route datagram lifetime. Like we saw in a bus topology that once a frame is launched in the bus topology, who will remove it, right? Who will remove it? Because uh, do you remember who removes the frame from the bus topology? Suppose if this station launches a frame F1, it will travel this side also, this side also. So who will remove this frame? Can you say?
Terminal.
These are the terminating resistances, right? Because the signal travels in the form of voltage pulses and it gets absorbed at the end. Terminating resistances absorbs it, right? But similarly, in a ring topology, we have seen that who will remove the frame in a traditional ring. It is the responsibility of the source station, right, to remove the frame, right? Once it is copied, once it reaches back to the source station, it is the responsibility of the source to remove it. But here you consider an environment here like an internet where uh, somebody should take care of it. Now suppose in your datagram there can be many reasons, right, that your datagram is not delivered. There will be header issues, right? Your header got corrupted, or there is some error in the datagram, or some different error, or maybe the router is unable to forward the datagram, to deliver it, right? Because the source end user is not available, or the link is failed. So there is a possibility that your datagram is not delivered successfully, because and there is no acknowledgement also, right? So what could happen, that this datagram may keep on traversing in the network, right? So it is not like घूमने से कोई problem नहीं है, लेकिन problem क्या है? See, once it is moving in the network, what it is doing? It is unnecessarily consuming the resources, because once again it will reach to the router will not be able to forward it, it will discard it, right? Or will forward it to our next station, to the next router. So like that, it is what unnecessary resulting in unnecessary utilization of the resources, right? Because the datagram can loop indefinitely, right? So it consumes resources. So there should be a provision that how long a datagram will stay in the network, right? Because everybody has got some life. Similarly, datagram should also have some life. After that, it will be useless. Okay. So based on that, to avoid these things, that if a datagram is not delivered successfully, it may loop indefinitely in the network and consuming the resources. So to avoid this, datagrams are defined with their lifetime. Okay. So each datagram is having a lifetime. This lifetime can be dictated in two ways. It can be dictated either uh, it can be a uh, true value of time, or it can be a uh, number of hops. So when I'm saying true value of time, what does it mean? It means that when you are saying about see, once the datagram is launched in the network, that time is recorded, right? And how long it will be there, we have dictated that this datagram will be there for 30 minutes, right? So after 30 minutes, that datagram will be that data. Basically, there will be a timer that will measure the time, that how long it is there. Okay, once it is reaching at some router will see that okay, iska itna samay ho gaya, it is there for this much time in the network. So then the router will discard it, right? So that is basically a true value of time. So once we will timestamp it, once the datagram starts, we will timestamp it, and that time will keep on running. And once uh, we will say that how long it has been in the network, based on that the router will discard it. Second possibility is that instead of that, we can have a number of hops that a datagram can travel. So every time it crosses one hop, because this number of hops are defined in the IP header. So the moment it crosses one hop, that decrements by 1. Suppose you have decided that it will go maximum up to 15 hops, right? So once it crosses one hop, it decrements to 14, then 13. So like that number of hops, once it reaches 15 hops, once it crosses 15 number of hops, the counter becomes 0, right? So so the time count or the hop count, right? So there is basically a time to live field in the IP header. So once lifetime expires, datagram is discarded. It is not forwarded further. Otherwise, it keeps on consuming the resources. So we talked about this fragmentation and reassembly in a larger way, like for a long time. And you know why the fragmentation is required, because different networks may have different packet sizes, right? And uh, so routers are supposed to fragment the packets before uh, fragment the datagram, so that uh, they can be made suitable to the other networks, right? So so fragmentation, we already discussed the pros and cons of fragmentation, that if there will be more number of fragments, there will be more overhead, right? And but there are advantages also, that the processing delay is minimal at each router for a particular fragment, right? But if there are too many fragments, there will be issues, right? And if you have lost one fragment, only a small portion of data needs to be retransmitted. So that is all advantages, and disadvantage is the maximum overhead, right? And more number of fragments, more processing time requires. So now when to reassemble? we discussed that whether it should be reassembled at the end user destination or intermediate reassembly. Intermediate reassembly means at some particular router. So what is the disadvantage at destination? That as the packets, as the datagram moves through the network, it becomes smaller and smaller till it reaches the destination, right? So that is a disadvantage if we are going for destination. But if we are going for an intermediate reassembly, what is the disadvantage? That first of all, it violates the dynamic routing concept, because once you have fixed that all the packets, all the fragments should pass through this particular router in the network, then that is basically violation of the dynamic routing, right? It inhibits dynamic routing because all the fragment must pass through this, and you require, if you do so, you require a larger buffer at each router, okay, and buffers may fill with fragments. So intermediate reassembly is not advised, though the packets get smaller while they move through the destination. But there are all provisions come into it, right? Then in IPv6 we have a don't fragment flag. So the routers, once that flag is set, routers cannot fragment it further, right? This fragmentation, how the fragmentation is done, we will do it in the next class, right? और जिसका टेस्ट नहीं दे पाया है, okay, they will post it in the teams that who has not given and what was the reason, right? They will write in teams. Thank you.